All right, let's talk about something called agentic AI. I know it sounds super technical, right? But trust me, we're going to break it all down with a problem that, well, every single one of us has faced. I promise. And that problem is this question right here. You know the feeling. You wake up, you're about to start your day, and you're faced with this mini puzzle. And it might seem simple, but let's be honest. Getting it wrong can totally throw off your whole morning. So what do? You grab your phone, you open up the weather app, and what does it tell you? 8 degrees Celsius, cloudy. Okay, but that's not really an answer, is it? It's just data. It's a number. Now your brain has to do all the heavy lifting. You got to translate that number into an actual decision. Like, what does 8 degrees actually feel like? Is that a sweater? A jacket? Maybe both? And that right there, that's the gap we're talking about. The gap between raw data and advice you can actually use. So let's look at how an AI team could solve this. Instead of one giant know-it-all AI, what if we built a system specifically to bridge that exact gap? A system that's more like a specialized team. And that, right there, is the core idea of an agentic system. Okay, so what is agentic AI, really? The best way to think about it is like a factory assembly line. You know, instead of having one single, massive, complicated machine trying to do everything, you have a bunch of smaller, specialized stations. Each station, or in our world, each AI agent, has just one super clear job, and they all work together in a sequence to create something awesome at the end. All right, let's meet the team. These are the digital specialists we've put together to solve our little clothing crisis. We've got 3 of them, and each one is an expert at its own little thing. First up, we've got the weather agent. You can think of this one as our data scout. Its one and only job, go out and get the facts. That's it. It doesn't try to understand the data, it doesn't have an opinion, it just finds the current temperature and reports back. Super simple, super reliable, totally focused. Okay, next on our little assembly line is the reasoning agent. I love this one. It's the sense maker. Its whole job is to take that raw number from the weather agent and actually give it some meaning. It's the one that answers the question, okay, we've got 8 degrees, but what does that mean in the real world? And here's what's so cool about this part. The logic here isn't hidden away in some mysterious black box. Nope, it's totally explicit. We can look right at it and see exactly how this agent makes its call. See? If the temperature is somewhere between 6 and 12 degrees, boom, it gets the label cold. This is huge because it makes the whole system easy to inspect and, trustworthy. There's no AI magic here, just simple, clear rules. And last but not least, we have our creative stylist, the outfit agent. Now this is where a large language model, an LLM, really gets to shine. Its job is to take that super simple label, cold, from our sense maker, and use its amazing language skills to write up a helpful, easy-to-understand piece of advice, just like a person would. All right, so we've met the whole team. Now let's watch them in action. Let's see how this little assembly line works, step by step, to turn one little piece of data into a full-on dress code. And you'll see, it's a really clean, simple flow. First, the weather agent grabs the data, 8 degrees. Then that number gets passed down the line to the reasoning agent. It looks at its rulebook and slaps the label cold on it. Finally, that cold label gets handed off to our outfit agent, who takes it from there and writes up the final recommendation. And voila! Here's what you get at the end. A clear, specific, and actually useful recommendation. See, it doesn't just say it's cold, it tells you what to do about it. That is the real power of getting these specialized agents to work together in one system. Now, I know what you might be thinking. This seems like a whole lot of effort just to pick out an outfit, right? But this method is actually so important when it comes to building bigger, more reliable AI systems. Let's talk about why this whole agentic approach really matters. So let's recap why this is so powerful. First, you have multiple independent agents, and each one does just one thing, but does it really well. Second, you have that super clear, explicit reasoning step that you can actually look at and understand. Third, you're using the powerful LLM for what it's best at, creative stuff, like writing natural language. And when you put it all together, this modular design means the whole system is way easier to fix if something breaks, to inspect, and to add new features to down the road. And you can start to see the potential here, right? Because it's so modular, we could easily swap out our simple weather agent for one that pulls data from a live weather API. Or, hey, what if we added a new agent that checks your calendar to see if you have a fancy meeting? Or maybe one that learns your personal style. The possibilities for making this system smarter and more personalized are just huge. So let's just end with this thought. We started with a really simple, everyday problem, right? What should I wear? But if a little team of AI agents can solve that so cleanly, just imagine what a bigger, more complex team could tackle. Think about huge problems in things like logistics or scientific research or even personal finance. Could they also be broken down and solved by a team of these digital specialists all working together? Well, that is the really exciting future that agentic AI promises.